Okay, so the program that I decided to use is Desmos.com simply because in today's day and time, Desmos is starting to become the new calculators for students simply because it's free and it offers so much more than just a basic simple function calculator. Desmos is now becoming to get implemented into standardized tests as well. So why would a student pay $130 for a calculator when they got all these tools with the click of a button for absolutely free? So I created a natural log function program that will show how to use Desmos and how to use the most out of it. So Desmos has all kinds of different things that you can use. For teachers, you can create an exam type layout. All you simply have to do is create a class code, go to the three dots over here, and you'll get a student link. You will click on the student.desmos and give that all to your students, and along with the code that is given right here, you'll give your students. Mine's already in because I already have the link, but you'll hit join. So students don't even have to sign up for this. Just think all they have to do is put your name, and you can get their scores, their input, and everything. So I put my name in there, and I'll hit go. So here's the first slide. It's sectioned out into different slides. So the first slide, I just put the directions of what they can do, and this is the other part of Desmos that I'll be using for this simple activity, which is right here. It's just the graphing calculator. Let me extend that some. I'll go back to this. So you got your directions. And I'll go to after they read the directions, I'll go to the next slide. So they can look at the graph. It's got a graph plotted out right here. It's also got their function over here that it'll show. The only downside is they can't edit the function, which is a downside to exams, because if they accidentally hit a button, then it could cause problems and test score issues. So after they look at the graph, this is just a simple them looking at the graph, because they will go to this, can copy that into here, paste it in here, and they'll create their sliders, and they can move around the graph all that they want, and just see the effects that it has. So after looking at this, is the base function. This is just changing all different kinds of variables in the function. So I'll go to the next slide. And now I ask them a question. After changing the A value, describe the effects that it has. So they can just go right back to the calculator, get everything back to 1. Well, it don't have to be at 1, but it's just easier to see. And then just start changing A and notice what the graph is doing. So they can come back over here, type in their answer, and it will share with the entire class. So not just I will see it, and I can make it to where I'm the only one that sees it. However, in this case, it's like a whole class discussion where each of the students can see what each other's putting. And I did this for each of the variables on the graph, A, B, C, and D. Next, I have them to, after they've looked at the graph, see the effects it has, they can predict what this function that I gave them. I changed it from the original function, which is the parent function, and gave them this. So they can graph it how they want. You just simply drag, and it'll graph this. They can cancel it, or if they mess up, like right here, grab the eraser and just erase it off, and then get right back to where they were going. And then I asked them to describe the effects that it has, and then they'll just simply type it in and then share it with the class. It's the same thing as the other ones. Now over here, I put up a graph for them to look at and then come up with the equation for the graph and see what answers I get from there, to see if they have a full understanding of how these graphs are created and the effects that each of these variables have.